Hello and welcome to the AI Research Roundup. I'm Alex. Today is May 12th, 2025. We are looking at a research paper from Hugging Face's trending list, published just 6 days ago, titled Knowledge Augmented Complex Problem Solving with Large Language Models, a Survey. This paper explores how LLMs tackle complex problems, examining techniques like chain of thought reasoning or COT, a process where models detail their step-by-step thinking. It also covers knowledge augmentation, for instance, using retrieval augmented generation, or RAG, where models fetch external data before answering to improve their solutions. Alright, so this first figure really sets the stage by showing us a variety of complex problem-solving scenarios. We see things like medical diagnosis, data analysis, mathematics solving, software engineering, scientific research, and even legal judgments. For each area, it highlights the kind of specialized or long-tail expertise required. Long-tail expertise refers to deep knowledge in very specific, often niche, areas. This visualization really drives home the point that LLMs need access to a vast and varied knowledge base to be effective across these diverse domains, a key challenge this research explores. Building on that need for diverse knowledge, this next figure illustrates two core paradigms of problem solving. On the top row, we see human approaches. First, cognitive science, where a person thinks through the steps, saying, first, I need, then I will. And second, computation theory, where someone decides, this can be done by code. The bottom row then shows AI mirroring these, and AI using similar step-by-step reasoning, much like chain of thought reasoning, and an AI generating code. This nicely visualizes how problem solving can be approached through detailed thought processes or by developing computational tools. Okay, so this figure then provides a case study, specifically from the field of machine learning. It maps out how an LLM might tackle such a problem, starting with user input like a machine learning question and data. The LLM then goes through stages like background understanding, data pre-processing, which is cleaning and preparing the data, then feature engineering, that is, selecting or creating the most informative input signals for the model, and finally, model training. This diagram also highlights the integration of external knowledge and a computational environment, and critically, where human experts might step in, especially for evaluation if results are unexpected. Following that machine learning example, this next figure, figure 4, depicts what the authors call the loops of complex problem solving. At the core, an LLM engages in multi-step reasoning, much like the chain of thought reasoning we discussed, pulling from various knowledge sources. Then, crucially, its outputs are verified. This verification can happen through another LLM, a symbolic verifier, which checks solutions using logic or code, or an experiment verifier, testing things empirically. We also see human-computer interaction, or HCI, that is, direct human involvement, playing a role in both loops. This visual emphasizes the iterative process. So, those iterative loops really underscore the ongoing efforts. To wrap up, this survey highlights that while LLMs show great promise for complex problems, they critically rely on multi-step reasoning approaches like chain of thought reasoning, and methods for knowledge augmentation such as retrieval augmented generation. A key challenge remains verification, especially for open-ended tasks. Future work will likely focus on richer knowledge integration, perhaps using knowledge graphs, which are structured ways to represent information and its relationships, and developing better verifiers, including concepts like LLM as a judge, where one LLM evaluates another's output. Thanks for tuning in to the AI Research Roundup.